This is my assignment first, and my name is Juan Mitten, and I will explain you my assignment one. So I will just talk about the libraries necessaries which are important, and I'm then just gonna start with the question one. So here I check the dimension of train images and train labels and test images and test labels. This helps us understand the structure of the data sets, right? And then I print them like the lengths of the training and test tables to verify the size of the data sets. For question 3, I displayed the first 10 training and test labels to get an idea of the class distribution. For question 4, I printed the digital content of the image at index 5 in the training set. So this shows the raw pixel values. So question 5 here. So I visualize the image at index 5 using a grayscale color map. So this actually gives us a better understanding of how the data looks, right? And for question 6, so I retrieved and interpreted the label for index 5 using the predefined list of label meaning, confirming what the image represents. Question 7. Similarly, I printed the digital content of the image at index 500 in the set, like a test set, to observe its raw pixel values. Right. Question 8. So I visualized. So here I visualized the test image at index 500 with a grayscale color map to see its actual appearance. Question 9. I retrieve here the label for index 500 and explain its meaning using the label meaning list. And question 11 here. Because the 10 was important libraries, so I just import from the top as you saw there here. So that's why I'm just keep going for the 11 one. So I initialize the neural network model and named my network using the sequential class. So question 12, that was the 11th. So question 12, I added a flattened layers to transform the 28 to 28 images into a 1D array for processing in the dense layers. I'm sorry. So question 13, we're going to talk about. So I normalize the pixel values of both training and test images by dividing them by 255, and this improves model performance, right? This is what I done here so far. So question 14, we're going to talk about the 14. So I added the dense layers with 512 neurons and ReLU activation for feature extraction. And the question 11 here, 16 here, I again added dense output layers with 10 neurons and softmax activation. And so I have softmax, so they classify the image into 10 categories, right? And there's question 17, there's the option A and B. So I will just talk again, option A and B. I'm just gonna divide them. So for EA, I complied the model with the ADEM optimizer and sparse categorical cross entropy loss. So then train it for 10 epochs. So after training, I evaluated the model on the task set and printed to loss and accuracy, right? And for option B, I switched to the RMS probe optimizer and the categorical cross entropy loss. So to use this setup, I converted the labels to categorical formats, retrained the model, and evaluated its performance, right? The question 21, I analyzed overfitting. Yes, overfitting analysis. So I analyzed overfitting by comparing the train and test accuracies. If the training accuracy was significantly higher than the test accuracy, I considered it as evidence of overfitting. Otherwise, no overfitting was observed. So this is the how output after I just run it. So you can see here also everything, and also you can see here, yeah, so the print gonna say no significant overfitting observed. So this is what I've done so far. So thank you for your time. Thank you for watching me.